we're going to see an example of a redox reaction balancing. So we are going to first write the oxidation number of each element in this reaction, and we have to remember some rules to write the oxidation number. First, that oxygen is always -2. The oxidation number of oxygen is always -2. Here we need all the elements of the group 1A of the alkali metals. We have are always +1. Also hydrogen is +1, and all the elements that are not combined with another element is 0, the oxidation number. And there are another rules that we are going to use in this example, but we have to remember also that the oxidation number of a compound, of a neutral compound, it has to be 0. So we are going to find the oxidation number that we don't know from the rules, and we are going to make the operation need to obtain this number. So we have -2 of the oxygens multiplied by 3, we have -6, and we know that potassium is from group 1A, so we have +1. Which number do we have to put here in order to have 0? We are going to find the X, that is the oxidation number of chlorine. So we have X is +6 minus 1 is +5. So here chlorine has +5. Then sulfur is not combined with another element in this part of the equation, so it has 0. This is the oxidation number of sulfur. Here potassium again is in group 1A, so it's +1. And to make this 0, we are going to write it -1. So +1 minus 1 is 0. So here chlorine is -1. In this one we have oxygen -2 times 2, we have -4, and to make it 0, it is plus. Sulfur here is +4. And now we are going to write to identify the element that change the oxidation number from this side to this side of the equation. And we are going to write them in half reactions that shows how the oxidation number changes from one side to another side. So we have chlorine +5, and here we have chlorine -1. Also we have sulfur 0 in this side of the equation, and sulfur +4 in this side of the equation. And now we are going to identify what happened with the oxidation number. First, here we have +5 and it changes to -1. This oxidation number reduces its value, and like electrons are negative numbers, well, and now to identify how many electrons does it gains or loses each element, we have here +5 to -1. We can see it in the numerical line. We have here +5, 4, 3, 2, 1, 0, and -1. We can identify here that it gains 1, 2, 3, 4, 5, 6 electrons, and here gains 6 electrons because electrons are negative numbers. So if it gains electrons, its oxidation number reduces its value. So gains 6 electrons. We say here that this element reduces its number of oxidation. And then from sulfur 0 to sulfur 4, it loses electrons because the oxidation numbers makes bigger, and it loses 4 electrons, and we say that it oxidates. And this one that reduces the oxidation number is the oxidant agent. This one that oxidates is the reductor agent. So we have here, we now identify how many electrons. If it changes from 5 to -1, we can say that it gains 6 electrons. If we add 5 minus 6 plus -6, we have -1. And in this case, it loses electrons, so we have here plus 4 electrons. In order that for -4, it results in 0 of oxidation number. So we are going to multiply, like cross multiply these reactions in order to balance the electrons. So we are going to multiply this one by 4 and this one by 6, because these are the number of electrons. We are going to multiply every element of the half reaction, 4 and 6, multiplied by every element of this reaction. So we have here 24 electrons plus 4 chlorines and 4 chlorine minus 1. And in this case we have 6 sulfur, and we have 6 sulfur in this side, plus 24 electrons. And we are going to add both half reactions. We write everything in this side of the arrows, in this part, and we write everything in this side of the arrows in this part. We have 24 electrons plus 4 chlorine plus 6 sulfur, and in this side we have 4 chlorine plus 6 sulfur plus 24 electrons. And we have 24 electrons in this side of the equation, so we can eliminate this here and this one here, because they are both in each side of the equation. These coefficients that we have in this part of the reaction, we can write it in the original reaction. We have here 4, 6, 4, and 6. And now we are going to make like inspection balancing in order to check that the atoms in the first part of the reaction are the same as that in the second part of the reaction. We write all the elements, sulfur and oxygen. We can count. This 4 is the coefficient and affects all the compounds. So we have 4 potassium, and in this side 4 potassium. In this case we have 4 chlorine and 4 chlorine. Sulfur we have 6 here and 6 here. And oxygens we are going to multiply 4 times 3, we have 12, and here 6 times 2, 12. So we see that after making the redox balancing, we have all the elements balanced. Thank you very much.